So now let's look at what happens when we generalize that model of biological competition to three competing species. So in this case, we could write the equations of motion the following general way. Ni dot is equal to n sub I, maybe with a growth parameter r sub I for each species, and then 1 minus competition terms, and the competition terms I could write as summation j equals 1 to 3 of alpha I, j, and j, where both I and j run from 1, 2, or 3. And this could be easily generalized to any number of species. Now, if you just stare at this set of equations, one sees that alpha ij, there's 9 of these guys, and there's 3 r sub i's, and so in principle, this is a 12-parameter system. We can always eliminate some of these parameters by rescaling the densities and also rescaling the time. So we have 4 possible rescalings, so we can reduce 12 parameters down to 8. That's still an awful lot. In order to analyze the system, let's simplify it further still. So let's consider the limiting situations in which all the r sub I are equal to 1. And furthermore, let us assume that alpha 1, 2 is equal to alpha 2, 3 is equal to alpha 3, 1. So cyclically permuting the indices. Let's all define these things to be alpha. And let's choose alpha 2, 1 equals alpha 3, 2 equals alpha 1, 3. Let me define these parameters as equal to beta. And furthermore, let me define that alpha I equals 1, 2, or 3 are equal to 1. So self-competition is one value. Competition between different species is given by either alpha or beta. So if we make these simplifications, we can now write our equations of motion as follows. N1 dot is equal to N1, 1 minus N1, minus alpha N, N2, minus beta N3. And the remaining two equations are just cyclically permuting the indices. So N2 dot is equal to N2, 1 minus N2 minus alpha N3 minus beta N1. N3 dot is equal to N3, 1 minus N3 minus alpha N1 minus beta N2. So these are the equations of motion that I want to investigate. Now this model, as defined, was introduced by May and Leonard in 1975, and they wrote a beautiful paper on the subject, so I'm following their treatment rather closely. And one feature that I want to emphasize here is part of the reason why this model turns out to be so interesting is that May and Leonard had the foresight to realize that by choosing alpha and beta different is what gave rise to interesting dynamics. So one can think of this as asymmetric competition, and it's this feature that led to interesting dynamical behavior.